Hi, it's Paul Anderson, and this is Science and Engineering Practices 1. Remember, what are practices? Practices are the skills and the knowledge required to do work. And so it all begins with asking questions and defining problems. In fact, these are the first steps in science and engineering. And so before we talk about asking questions, we should really define what science is. Science is the study of the universe. It's the study of everything. It's the study of phenomena at the level of the universe, but also at the level of the planet or the ecosystems or the humans or the DNA or the atoms that make up that DNA or even the particles that make up the atoms that make up everything. And so basically it's the study of the phenomena. It's the study of how things work. And we try to explain everything in science, everything scientific. What's engineering then? Engineering is going to be solving human needs or fulfilling human needs, solving problems. And so an engineer is going to solve the problem of how I get in Montana at point A to point B in New York City. And there are a number of different ways they could solve that problem. They could put me on a jet, they could put me on a train or in a car or on a motorcycle, or they could even design a nice pair of shoes so I can walk my way across the country. And so they're really solving problems in engineering. And so they're very similar, but they're somewhat different in that in science, we're studying phenomena. And let's talk about a famous scientist. This is Albert Einstein. And so what he was trying to allow us to do was to understand the way the universe works. And the first step when you're trying to do that is to ask good questions. Those questions eventually lead to inquiry, where those questions are tested and they develop other questions or other theories based on top of that. But the whole goal, again, is pointing back to explaining how phenomena work. Well, this here is Thomas Edison, and he was somewhat scientific, but he was more of an inventor. He was more of an engineer, and that's because he was fulfilling human needs. He started by defining problems that we have. What was a simple problem? Well, if it was dark out, you couldn't do work inside, and he invented the light bulb. And so the first step in engineering is defining a problem, and then you have the process of design. Unlike inquiry, design is there to give us something, to build something, or to fulfill some kind of a human need. And so there's a lot of similarity between science and engineering, but the major difference is going to be that in engineering, we're making something that we actually need. In science, we're trying to explain everything, and we don't always have a direct outcome from that. However, science lots of times will lead to design. And so it all begins with good questions. And so let's start by talking about science. Where do these questions come from? Well, in science, a lot of them come from just curiosity. We want to understand the way the world works. And so if you were to ask this question, why is the sky blue? Or why does the wind blow? Those are great questions, and they can lead to amazing science. But some science questions will actually come from models and theories that we already have. So once we understood plate tectonics, we could apply that to seafloor spreading. So how does the theory of plate tectonics explain seafloor spreading? So theories create questions, which create theories, which create more questions. And sometimes questions just come from the search for better solutions. And so people in Italy were finding that it was impossible to siphon water above 32 feet. And so Evangelista Torricelli in Italy took a look at this problem, and eventually it led to the creation of the first barometer and understanding how air pressure and atmospheres work. And so again, questions can come everywhere, but they guide inquiry. Now, one thing I really want to make sure that I point out is that there are questions that we can answer using science and questions that we can't or lay outside of science. And so if we were to look at these hot air balloons, a good question might be, why does a hot air balloon float? That's a scientific question. What's not a scientific question? Which hot air balloon is the prettiest? Now, you might like the ladybug right here, but we can't really answer that question. We can't quantify that answer. And so there are certain questions that lay outside of science. Now let's go to engineering. And so engineering has questions in it as well, but those questions are designed to first of all define the problem. And so here's a really good problem. This is the Mars Curiosity rover. It landed on Mars in August, and it's about the size of a car. And so the engineers at NASA had to come out with a way to land this massive object on Mars without damaging it. And so they started by asking a lot of questions. Now, one thing that we should point out, and this is again a difference between engineering and science, In science, we're looking for this core idea that explains the way the world works. In engineering, we're looking for a design that solves a problem. And so in engineering, there's not always one correct solution. There's going to be a number of different solutions, and we're going to have to weigh the trade-offs with all of those solutions. And we do that through questioning. And so maybe when you're trying to land a rover on Mars, you need to talk about what are the needs? What do we really need to create? What are the criteria for success? In other words, what does success look like? What are the constraints? I mean, on Mars, one of the big constraints are going to be you're going to have to go through an atmosphere, but that atmosphere is going to be really, really thin. And so that's going to slow you down, but not slow you down very much. What technology do we have today? What are we going to have to create as far as technology? What ideas should we test? Could we combine ideas together? And so really the questioning in engineering is really designed to define what that problem is, or to get at that problem. This is how they actually landed on Mars. They had a capsule that slowed their descent. They eventually had a giant parachute that slowed it down. They eventually deployed a crane with rockets that lowered the Mars observer down onto the surface. And so you can think of all the different needs that they had to fulfill, all the problems that they had to solve. And it had to do this on its own. You couldn't guide it down. And so it's a pretty amazing thing. And you could Google, there's a wonderful video that's worth watching on that. And so again, the goal in this practice is to ask questions. But we're asking questions to explain phenomena and then provide human needs or fulfill human needs. And so how do we do that as teachers? Well, we start by asking questions, and then we use inquiry to explain those. And in engineering, we start by defining our problems, and then we're using design to solve those problems. And so there's a progression. In other words, as a teacher from elementary through high school, we should be getting better and better and better at asking questions. But we should begin by asking questions. And so when you're in elementary, this is an analogy that I think works well, is that the idea of asking questions in science and engineering and technology is very important, and you want to do it right away. But as students get older and older and older and older, we want to refine those questions and get better and better at questions. And so basically, you want to develop strategies in your classroom that can help students come up with questions on their own. Because questions are going to build more questions, which are going to build more questions. And so you want strategies to get your students asking questions, but once you have a number of questions, you want to teach them, refine that. Like, which of these following questions are really good questions? Which are science questions, questions that we can actually answer through design or through science labs. You want to eliminate science questions that aren't really questions at all, and you want to refine other questions so you can make them better. Because the goal of science classrooms is to get students asking good questions, questions that we can then do research upon, or questions that can define problems, and so we can come up with solutions for that. And I hope that was helpful.